Hello everyone, I'm Rashmi here. Today I'm going to discuss about sound. How is sound produced? How does it travel from one place to another? How do we hear sound? In this slide, I'm going to discuss about all the three questions. First, look at the definition. Sound is produced by the vibration of materials. It helps to communicate with one another. We hear a variety of sounds in our surroundings. Vibration is the to and fro or back and forth movement of an object. This can be explained with the help of three pictures. In first picture, if we take a pen and hang it in such a way that it should not touch the wall, and now strike it with a stick, we hear the sound, and if we touch the other hand, we feel the vibrations. If we stop striking it, there is no vibrations and we don't hear any sound. Thus we can say sound is produced by the vibration of materials. In this picture, pencil box, two pencils and the rubber band have been taken. Rubber band has been put around the pencil box, that is the longer side of the pencil box, and two pencils, this one and this one, have been inserted between the stretched rubber band and box. Now plug the rubber band somewhere in the middle. We hear the sound because the sound vibrates. If it stops vibrating, it does not produce sound. In this picture, take a metal plate and pour water in it. Now we strike its edge with a spoon. We hear the sound and the dish is vibrating. Strike the dish or plate again. Can we see waves in the water? Yes, we can see waves at the surface water. Thus we can say sound is produced by vibration of materials. Musical instruments and their vibrating parts. Veena, its vibrating part is stressed strings. Tabla, stressed membrane. Flute, air column. Sitar, stressed string. Mridangam, stressed membrane. Kartal, air column. Drum and dholak, stressed membrane. Sound travels through material medium from one place to another. The medium may be solid, liquid, and gas. It cannot travel in vacuum. In some cases, we cannot see vibrations. Why? Sound needs a medium to travel. Like this picture, take a metal or glass tumbler. Here, glass tumbler has been taken and the glass should be dry, and place a cell phone in it and ask someone to give a ring to the phone. Listen to the ring carefully. Now surround the rim of the glass with the hands and put mouth on opening between the hands. Indicate the friend to give a ring again. Listen the ring while sucking air from tumbler. We can hear the decrease in the loudness of sound. When air is completely sucked from the tumbler, we cannot hear any sound. Thus, we can say that there is vacuum and sound does not travel through a vacuum. Does sound travel through solid? This can be explained with the help of this picture. In this picture, two boys are standing on the opposite sides of the wooden table. One is making the sound and the other is trying to listen. Yes, the other can hear the sound. Yes, we can say sound travels through solid. Does sound travel through liquid? This can be explained with the help of this picture. Like this picture, take a bucket and fill it with water. Now we take a small bell in one hand and shake the bell inside the water to produce the sound, but it should not touch the body of the bucket. Now we place the ear gently on the water surface. Can we hear the sound? Yes, we can hear the sound. Thus, sound travels through liquids. Does sound travel through strings? This can be explained with the help of this picture. In this picture, two boys are there. Both the boys are holding the cans, and the two cans have been connected through strings oblique wire. One is speaking through it, and the other is trying to listen. What he is speaking, yes, the other boy is able to hear. Thus, we can say sound travels through strings. In some cases, vibrations are not visible due to very small amplitude. How is sound produced in humans? In humans, the sound is produced by vocal cords present in voice box larynx. When the lungs force air through the slit present between the cords, these are the vocal cords, air passing through the slit causes vibration in stressed vocal cords producing sound. Human ears. How we hear sound through our ears. This is the picture of the ear. This is the outer ear. This is the inner ear. And this is the middle ear. This is the eardrum. And this is the canal. Sound enters the ear through the ear canal. It enters through it. It makes the eardrum to vibrate. The eardrum sends vibrations to the inner ear, and from there the signals go to the brain, and then we hear the sound. Amplitude, time period, and frequency of a vibration. Oscillatory motion, the to and fro motion of an object, is known as vibration. This motion is also called oscillatory motion. Time period, the time taken by a vibrating body to complete one oscillation is called the time period. Frequency, the number of oscillation by a vibrating body in 1 second is called the frequency. Unit of frequency, its unit is hertz. Human ear can hear sounds of frequency between 20 hertz and 2000 hertz. Dogs can hear sound of frequency more than 2000 hertz. Amplitude, the maximum displacement of an oscillating body from its central position is called amplitude. Loudness of sound depends on the amplitude of vibration. It is proportional to the square of the vibration producing the sound. If the amplitude becomes twice, the loudness increases by a factor of 4. Its unit is decibel. Here, it distinguishes between loud and feeble sound. It mainly depends upon the amplitude of sound. Other factors are the area of the vibrating body and distance of the listener from source of sound. Amplitude, high amplitude, loud sound, low amplitude, feeble sound. Pitch or shrillness. Frequency determines the pitch of a sound. If frequency of vibration is higher, higher is the pitch and the shriller is the voice. It distinguishes between shriller and flatter sound. It mainly depends on the frequency of the sound. Higher frequency, shriller sound, shorter wavelength. Low frequency, flatter sound, longer wavelength. Quality or timbre. It distinguishes one sound from another, having the same loudness and pitch. Both the sounds have different sound effects, sound waves of guitar and sound waves of sitar. Loudness and shrillness can be explained with the help of these two pictures. In this picture, take a metallic tumbler and a tablespoon and strike the tablespoon gently at the rim of the tumbler. We hear the sound produced. Now bang the spoon hard on the tumbler and hear the sound produced again. Yes, the sound produced second time is louder than the previous one. Now suspend a thermocol ball touching the rim of the tumbler. Vibrate the tumbler by striking it. Now see how far the ball is displaced. The displacement of the ball is a measure of the amplitude of vibration of tumbler. In this picture, drum vibrates with a low frequency. Thus, it produces a low-pitched sound. In the case of whistle, it has a high frequency and therefore produces a sound of higher pitch. Like a bird makes a high-pitched sound, whereas a lion makes a low-pitched sound. Noise pollution. Presence of unwanted or excessive sounds in the environment is called noise pollution. Causes and harm. Causes are sounds of vehicles, machines, crackers, loudspeakers, etc. contribute to noise pollution. Excessive noise may cause lack of sleep, hypertension, anxiety, temporary or even permanent impairment of hearing. Measures to limit noise pollution. Noise producing industries should be set away from residential area. Airports should be made away from residential areas. Silencing devices must be installed in aircraft engines. Use of automobiles horns should be minimized. TV, music systems, loudspeakers should be run at low volumes. Trees should be planted along the roads and around the buildings. If you have any doubts or clarifications, feel free to contact me via email. Thank you, everyone.